In this video on factorial notation, we will first learn to simplify and evaluate expressions that include factorial notation, and secondly, we will apply these skills to be able to also solve equations that involve factorial notation. When working with combinatorics and counting problems, we often come across expressions and equations that involve this factorial notation. We will use this video as an opportunity to practice simplifying, evaluating, and solving these types of expressions and equations so that we're able to successfully apply these skills when solving counting problems. Now, you might be wondering, what do these types of expressions and equations actually look like? On the left of the screen, I've included an example of two expressions that involve factorial notation. The first example is one with numbers only, so we describe that as being a numerical expression. And the second one involves variables. We describe this as being an algebraic expression. On the right-hand side of the screen, you'll see an equation that involves factorial notation. Keep in the back of your mind that only natural numbers can be possible solutions for those equations. Before we get to our first example, let's just refresh our memory about what factorial notation actually means. So recall, it's a concise representation of the product of consecutive decreasing natural numbers. So if I had the expression n factorial, I would start off with the value n, whatever that might be, and then my next factor would be n minus 1, n minus 2 would be the next one, and I would continue on all the way down to 1. I'd stop there because 1 is my last natural number. Let's begin by looking at a few simple numerical expressions. Example 1 asks us to evaluate the following. The first one in part A says, evaluate 10 factorial. Now that looks like an easy one, and you'd be right. All we have to do is use our factorial button on our calculator to evaluate it. But just to be sure that we understand what's going on here, let's write out a few more of these factors. So recall that 10 factorial means that I would start at 10, and then I'm going to write out the rest of the decreasing consecutive factors. So I'd go 10 times 9 times 8 times 7, and I would continue on all the way down to 1. Now, when I actually evaluate that, or when I use the factorial button on my calculator, I would find that that's 3,628,800. Now we're going to take a look at part B. Now, at first glance, this expression looks to be quite a bit more complicated. However, if we can use simplifying to our advantage, we can make our life a whole lot easier when we go to evaluate this. Let's start by writing out a few of these factors to see if we can simplify this expression at all. Now I'm going to start by writing out 12 times 11 times 10 times 9, and I'm going to write a factorial symbol there. Now here's why. If I look at the top and the bottom of my expression, I've got a 9 factorial on my numerator and a 9 factorial on the denominator. That means that those will divide out to be 1, or they'll cancel out. Now let's look to see if we can cancel out anything else. Let's recall that 3 factorial is actually the same thing as writing 3 times 2 times 1. Now that's equal to 6. And I know that that can divide into 12, which leaves me with 2 on the top. And finally, I've just got this nice simple multiplication at the end that's just 2 times 11 times 10, and that just leaves me with 220. In our first example, we looked at numerical expressions, which means that we only had numbers involved. Now, this time in example 2, we're going to dig into some expressions that have variables involved. We call these algebraic expressions. It's important to remember that that variable represents a natural number. Let's start by looking at part A. This expression reads n plus 3 times n plus 2 factorial. So as I'm sure you can guess, we're going to start by writing out some of these factors to see if we can manipulate or simplify the expression in any way. So n plus 2 factorial, if I write out more of those factors, the second factor would be n plus 1, because that's the next decreasing factor from n plus 2. Then if I subtract 1 again, I'd be left with n. And then my next factor would be n minus 1. Then I'd have n minus 2. And I would continue on all the way down to 1. Now, let's look at that part that I've underlined there. Turns out that this is just a more complicated way of writing out n plus 3 factorial. So in my last step, I'm just simplifying the expression to say that this actually just means n plus 3 factorial. All right, let's see if we can apply this in a more complex expression. So in this scenario, we've got n plus 1 factorial on the top, and I am dividing by n minus 1 factorial. So same tactic as usual. I'm going to start by writing out some of these factors. So let's start on the top. I've got n plus 1 factorial, so my next factor would be n, and the one after that would be n minus 1, n minus 2, and so on and so forth. Now, if I expand the denominator, I would start with n minus 1, which means that my next factor is going to be n minus 2, and then I'd have n minus 3, and so on and so forth. Now, if I look here, I can start to cancel some of these factors out. So I can cancel out n minus 1, n minus 2 factorial, and so on and so forth with the two factors on the denominator. So my simplified expression is going to be n plus 1 multiplied by n, and if I just multiply those together, my final expression would be n squared plus n. All right, let's dig into our last example. This one is asking us to solve an equation that involves factorial notation. So you can see here that I've got n factorial divided by n minus 2 factorial, and that's all set equal to 90. Now, just a reminder that n holds the place of a natural number here, since we're talking about factorial notation. Now, before I try to solve this equation, I'm going to see if I can simplify this to see if I can make the solving a little bit easier. As a visual, I'm just going to start by writing out a few factors, just like I did in the previous examples. So n factorial would be the same as writing n times n minus 1, n minus 2, and so on and so forth. And then if I take a look at the denominator, I'm starting with n minus 2. And so my next factor would be n minus 3, n minus 4, and so on and so forth. And that's all set equal to 90. So you can see that a few of my factors are going to cancel out here, and I'm going to be left with n times n minus 1 is equal to 90. So if I just multiply those two factors out, I've got n squared minus n equals 90, and you might be thinking, well, how am I going to solve this? Well, we're going to have to dig all the way back to quadratic equations and our knowledge of factoring. So I'm just going to start by subtracting a 90 from both sides, and I'm going to set my quadratic equation equal to 0. So I've got n squared minus n minus 90 is equal to 0, and my task here is to find two factors that are going to add to negative 1, because that's the coefficient in front of n, and that are going to multiply to negative 90. So my two factors here are going to be negative 10 and 9. That would add to negative 1 and multiply to negative 90. So if I write out my two factors, I've got n minus 10 multiplied by n plus 9, and that's all set equal to 0. If I split those apart into the two possible solutions, I can see that I've got n equals 10 and n equals negative 9. But before we check those off as both possible solutions, we just need to make sure that we understand which one of those truly is the solution. So in this case, remember we're talking that n can only be defined for natural numbers, which means that our negative possibility here, -9, cannot be a possible solution. Therefore, our only solution is n equals 10. And just like with any other equation, we can check to see if we're right by substituting our solution into the original equation. So if I substitute 10 back into our original equation and simplify the left side, I can see that 90 is in fact equal to 90, and 10 is our solution. To summarize what we've learned in this video, when working with expressions and equations that involve factorial notation, we can simplify before we have to evaluate or solve, and we use our knowledge of factorial notation to do so. And secondly, when we solve an equation using factorial notation, it's important to remember that only natural numbers are possible solutions.